you are watching it just start to plummet down to the ground. Yeah, that's nerve-wracking. All of a sudden, smoke starts pouring out. Are we good? Are we rolling? My name's Theo Udes. Do we want surnames? Cool. Then I'll just do Theo. You can bring up my full name at the bottom, my LinkedIn. I'm the founder of Lura, and I've been the project manager of the Aptos project. Lura is the Leeds University Rocketry Association. So I set the team up 2 years ago in order to provide aerospace opportunities for Leeds students. Our mission we call Preparing the Mars Generation. Basically, it's this generation of people, the engineers, technicians at university now, that will be the future astronauts, engineers, and everyone working on the team that will take humans to Mars and make humans interplanetary. In the Project Aptos team, we had myself, Jordan, Joe, Liam, and Ben. And then for this weekend, for the launch campaign itself, we have Dom, who's been our flyer of record, who's been flying the rocket. And Toby, who's here, he's the chief engineer of Lura, so he's been here as technical support and helping with everything that we need over the weekend.
So I'm Liam, and I was principally the structural engineer for this project.
Hi, my name's Joe, and I was the manufacturing / helping out in general person, I think, on this project as well as.
I'm Jordan, and I was mainly in charge of sort of the aerodynamic side of things on the project. The aerodynamics wasn't sort of the main purpose of the project, but it still was important to do so that we had accurate data that we could send over to the software guys so that they knew, you know, how far do they have to turn these wings in order to move it aerodynamically.
My name is Stan. My role in this project was basically doing the electronics, for that went in the module. There's one bit which is taking in like what the orientation of the rocket is, whether it's tilted to the right, whether it's tilted to the left, and then calculating what it needs to do to get the rocket to go back to vertical. Taking lots of sensor readings and putting them all together and finding out what to do. Hopefully we shouldn't kind of spin in the air or like go and hit the ground or something. So yeah, that's kind of like that's the overall kind of two bits of it that matter that I've done, and you know, in very short terms, I guess that is literally all I've done.
There's nothing then. Yeah, only two things.
So after performing an aerodynamic analysis, we found that we couldn't use Lura's G1C rocket, which was our original plan. And so because of that, we created our own rocket, Pathfinder, and that will be entirely designed, manufactured, assembled and tested all by a small team. Our goal isn't necessarily to fly really high, it's just to test our system. So at Lura, we're aiming to beat the UK student altitude record, and as a part of that, we made Project Aptos, which was to create an active control system on a rocket. The aim of this was to reduce weathercocking into the wind, which means that they're not flying as straight as they could do, which means they're not going as high. So if we can counter that, we can get higher and therefore beat the record.
Then when we moved into the actual building and assembly of the rocket, that took a long time. So a lot of time spent on the 5th floor with the engineering building. Moving past that, as soon as we kind of got those drawings signed off, we were then looking at the design of the module and how we were going to kind of seat the canards, how we were going to link the servos and the canards, and how the module was going to be integrated into the rocket itself.
Now we have these three rings that are going to support the structure of the aft tube of the rocket.
I was involved quite a lot with the 3D printing, so made friends with Reese at the university, which definitely helped because he fast-tracked a lot of our stuff.
So welcome to the wind tunnel that we have here in Leeds. So we've been using this to test our canards that we've custom 3D printed. So this is the intake, but we'll come around to the side. Here there's a load cell. So this isn't our setup, but when we did it, we had our canards in there attached to the load cell. We did various wind speeds so we could test the aerodynamic properties of the canards. And then obviously we send that over to the geniuses of Ben and Theo in software so they could sort of figure it out and put that into the model.
So we're trying to fit, we have a bunch of different components that are going to fit onto that motor tube. One of them being this bearing. So the idea is, the issue is that we can't fit them on, which is completely the plan that's designed that way. So what we're going to try and do is heat the bearing up and cool the aluminium down, fit the bearing on, and then once it's on and they go back to normal temperatures, it shouldn't come off again. That's the plan.
It's T-minus 3 days, and it's B to the launch. It's been a pretty difficult one. Basically, been putting together this thing today, or over the past couple of days, and today there were just like so many issues. Everything that went wrong basically could go wrong. These battery cables, the tiny ones, that for some reason the red and black are different to what they normally are. So that was the first thing. The Bluetooth module, which we use to, when it's inside the rocket, obviously we can't plug anything into it. That broke as well. A couple of the pins that connect the two PCBs were just the wrong way around, and I just hadn't noticed that when I was designing them. But
So that one was your fault.
that one was my. I could see I made one mistake. Well, it probably was. Should have checked a few things, but yeah, it's just been a really, really long day. I'm hopeful, but it could be a long night tonight. So we'll see. Yeah, we'll see.
We left painting so super late, so we ended up painting it at really late the night before. I think we were going up to Scotland, and then we left it to dry, and then the next day we were like, okay, time to go up to Scotland. It's painted, it's done, it looks beautiful, got loads of compliments on it. The drive was long, but it was great, and it was just good fun being in the car with like good friends and just having good chats. And then we arrived here at the lodge where we're staying. It's like a sort of scout camp, and it's just really good vibes. We've set up our workshop, we've got all our tools here, everything's here, we've got all the lads are here, and there's just a buzz in the air when we arrive instantly. And we knew it would be a late night on a Friday night, just getting us all prepared for Saturday, but we were all like so willing to do it. And we'd only had very little sleep the weeks before, but we were all like, oh, we don't care, we just need to batter this out, get this rocket up tomorrow.
So Saturday, the day of our first launch, we needed a 6-meter launch rail. So you put the rocket on a rail to launch it. We need 6 meters. We've worked with various different people to try and find a rail for this weekend, and we found one. When they arrive, they're missing 2 meters of the rail. That knee-jerk response, oh, and I can tell you right now, we cannot launch on a 4-meter rail. So it's a bit emotional. I was a bit hot-headed, but we moved through it, and through a series of phone calls between the guys at base camp, myself, the guys who are at the launch site, your Glasgow rocketry team who are half an hour away. There's this sort of network of calls that are going on, and we are all working separately and just trying to solve this problem. Those moments and looking up to what has been done before has really inspired what we do now.
So yesterday we had a few interesting moments, to say the least, and then obviously there was the little fire that we had.
We were all pretty nervous anyway, kind of setting up. This is the first time going to launch a rocket with rocket. We were going through these procedures, and then when we start screwing this in, like it's kind of not going in properly, so we kind of have to remove it a couple of times, fiddle around with the wires. I kind of know it's happened before. It's pretty much every time we put it in, we have to kind of fiddle around a little bit. But this time it's like especially bad, and it's like taken 4 or 5 tries to be able to get the module in. And then we finally managed to like kind of probably a little bit too hard, push it in. Theo starts screwing on the first bolt. And then the smoke starts coming out the holes at the top of it and on the side. And like the first thing we all thought was the battery's on fire. And that we've burned the PCBs, so they won't be able to work anymore. Literally like the whole weekend is kind of pointless now. That's like the first thought that I think went through everyone's mind.
And suddenly I just hear Theo shout fire, and I was like, what?
I mean, it was myself that was literally screwing the bottom plate on the module, putting the circuit boards in, when all of a sudden smoke starts pouring out of the holes in the side of this module.
Oh, no. Oh. Right.
That's the battery. That's the battery.
Right. Yeah, get it out.
And Joe was amazing. Theo unscrewed the bolt. Joe literally like, I didn't even have time to react. I was kind of just stood there like, oh no. But Joe was like, hands on, grabbed the module, took the things out, and like unplugged the lipos, the batteries straight away. Yeah, I was like very impressed. I kind of just stood there like, oh, this is not good.
As soon as you see smoke in an electrical component like that, you know there's trouble, and that is such a scary moment, because that is just game over at that point. Any of the components go, and you're not flying the rocket.
I have never had that happen. I've never had, I mean, we had a fire in the active control system. That's never happened before. That's a really bad sign.
This was our very first launch of this brand new rocket that we built with this brand new module that we spent so much time thinking about and working through. And suddenly you're there and you see smoke.
We put in the module, the insulation on the wires was getting damaged like ever so slightly, and literally happened to be on that time we put in the module so many times on the PCB so many times, literally the time that we're about to do the flight, and then obviously the smoke started coming out. So fingers crossed we can get back on the road. And to be honest, I didn't think we were going to launch. And then Toby obviously came in and helped massively.
Toby comes over, starts instantly diagnosing the problem. We got the multimeter out, we're checking which cables aren't working, we're electrical taping.
In that moment, it was all Toby who was calm. He was like, right, let's just have a look at it, let's open it up, let's see what's the problem. He just jumped right into action. It was really good that everyone knew the system so well. Like Ben stepped in, he was like, oh, you don't actually have to connect that red wire to this point, you can just connect it to that point because it does the same thing and it's easier. And so luckily, like, we knew our system really, really well to jump in, make quick decisions, and effectively that saved the launch because, yeah, we only had 3 minutes left by the time it launched before we weren't allowed to launch anymore. So thanks to the quick thinking of Toby and Ben in particular, and Joe pulling it out, and just all of us rushing around, and we made it work. Something that's really important to consider is that we only have a very certain flight window. It's called a NOTAM that's put up, and basically what that means is that there's a certain radius around the launch site where air traffic cannot go through up to a certain level. So ours is up to a certain height, and this is like a big cylinder, a physical, like an invisible cylinder that planes cannot go into because we're telling them we're launching rockets, don't come near. And so that window was from 1 p.m. until 7 p.m. And then the fire broke out around 6. And then after we sort of sorted that like stopped the fire on the smoke from happening, that was like 6:15 or so maybe. And I looked at my watch and I was like, oh, we've got 45 minutes to get this on, go through all the procedures, making sure everything's safe, and get it to launch before this NOTAM area is then invalid and we're not allowed to launch anymore. So when we put it on and it was just sitting there, and we're like, oh, is it stable, is it okay? And we're like very, very delicate about it. Because obviously this is all our work for the entire year has come to this moment, and it all rests on this moment to see if it's successful or not. Me and Theo are standing there, and I think Toby was there too. The rocket is on the rail, we're looking at it, and because we had to do this like bodged job to get that extra 2 meters on, there are these like screws that are sticking out the side a little bit, like here. And obviously, the whole purpose of our project is to have this control system, these fins at the very top, canards. And these canards are sticking out like this on the rail because it's this way, and the nuts and the screws are sticking out this way. And we looked at it and we were like, hang on a second, that's gonna clip there. Like if that's gonna shoot up, that will clip.
The gap looks quite significant. Seeing that in the canard at all. Hold on.
It's just something that was worth.
Hold on. This isn't right. Canards aren't. Look, this canard is too close. That's gonna hit this box. Yeah, this canard is way too close compared to the other side.
Very last minute, we're like twisting the rocket, we're actually twisting the top bit separately from the bottom bit to make sure that the canards aren't gonna hit anything. We're like, yeah, that one's just about to pass. That's gonna pass. We're like, it's 6:57. We need to launch the next 3 minutes. We can't take this down and readjust this. We're like, looks good. Let's go. And obviously, we judged that to be safe enough. Otherwise, we wouldn't have done it. But that was a really frantic moment, and it just shows that there's always like a problem to be solved. When it finally launched and it's going up, it's just the excitement that it came off the rail. Okay, it's gone up, and it's just exciting.
You see it sort of like curving all the way upwards, and then like once the rocket burns out, you've got this like silence.
I can't tell you. I mean, that's a hell of a feeling. That's a hell of a feeling.
3, 2, 1, on.
Here it comes. Come on.
Oh, you need to open. Yeah!
And I remember, like, I was there with a camera just filming it, and everyone was just cheering and jumping. I think I got so unsteady when I was filming because everyone's jumping and grabbing me and hugging me, and like these guys, I don't think they're particularly like huggy guys in the team, but then in that moment there was a lot of physical contact and everyone was just grabbing each other, and it was real like moment of unity amongst the team. So that was like definitely the highlight of the week for me.
Theo, you are gorgeous, Theo.
The parachute pops and they're like, oh, everyone hugs each other. Like, it's just so many emotions in such a short amount of time.
When we actually like see it go off the rail and sort of eject and fly, it's hard to describe. It was a bit of a track. It took us a good sort of 15 minutes to get here to the rocket.
We've got eyes on it, so it's so easy to see. So it's right on the edge of that hillside. It kind of blends in with the sheep, doesn't it?
And then when we got there, it's like, okay, quick, like, is anything broken? Is anything damaged? You kind of photographing everything. So one of the canards had fallen off, and it looked a little bit messy, but everything else seemed to be in decent condition. Like the parachute had done its job and got it down at a safe speed. None of the airframe had damaged or anything like that. And then so we kind of bundled up the parachute, picked it up and started walking back victoriously.
So after we went and collected the rocket, after it landed, we found that one of the motors had actually broken. And so because of that, we had some late meetings together, sort of discussing what we could do, seeing if we could fix it. But at the end of the day, we found that it probably wouldn't be safe to try and launch the rocket using the active control system the next day. But despite that, we did get really good data from the first launch, and so we decided next day that we were going to launch again, doing exactly the same test as the first day, which was flying it without the active control system, just to see how the rocket flies on its own.
The clock's still ticking, the game's on. So yeah, we go to bed, we wake up early in the morning, page 1 of the procedures, let's go. We work through the whole thing. And as always, the second time you do things, it runs a lot smoother. We get through the procedures a lot quicker, not without hiccups. We rebuild the cable that had started the fire the day before, and we get to the launch site this time about 3 p.m. And that is just a massive thank you to specifically Paul Carter, Colin Rowe, Chris Brown, John Bonser, Stuart Livings from Wizard Rockets and Wizard Rockets in general, and generally the UK rocketry community. Over the last few years, we've built a real family of mentors and people in the industry that have helped guide our designs. And with this project specifically, doing something quite innovative, doing something very experimental and very failure prone, they've been really helpful at guiding us and frankly keeping us in check, making sure we don't do anything stupid, which, you know, sometimes you do need some boundaries. But yeah, and especially for John Bonser, who's been the range safety officer this weekend, and just thank you so much for everything you've done for the team. And I hope that after I leave the team to continue without me, that our relationship continues, and that Lura can continue to support the work that you do at Fairley Moore, and that you can continue to support my team into the future.